We are jumping into section 3.5. It says we have already looked at three rigid motions, translation, reflection, rotation. Now we are going to look at doing them back to back. So on here, it has, you can see several different triangles, and using the prime notation, you can tell which one comes first, which one comes after that, and which one comes at the end. So let's go ahead and you're supposed to write down the specific names using all correct notation about how you get from the very first one all the way to the end. So at first you can see there's a reflection going from the non-primes to the primes. It's reflecting, and it's reflecting over a vertical line, so that's x equals, and it's at x equals 3. Now we're at the single prime, and we're going to go to the double, and you can see that is just a shift. So we are going to be translating left 6 and up 6, and then you end up at the double primes. And then at this point, it appears that it is rotated counterclockwise, and it is rotated by 90 degrees around the origin, which is 0, 0. You could always test a point just to make sure that it's actually rotating around 0, 0. Just see if it goes along with the rules that we learned in the previous lesson, and it does. So that is it's called a composition of transformations. On the next one, it asks us, it says, there are two different graphs below. I want you to do back to back. It says translations. It's supposed to say transformations. And then it says, but I'll be switching the order that you complete them. So you first go over and take your triangle, go right 1, down 3, redraw it, and then flip over the y-axis, and you can see where it ends up. The next one, you're first going to flip over the y-axis, and then you're going to go right 1, down 3. The question after that says, what do you feel like you can say about the order that you complete transformations when doing number 2? While it kind of appears that the end is the same location, it's not. On the first one, C double prime is at 1, negative 1, and on the other one, it is at 3, negative 1. So they're different locations. So what we can say is that the order seems to matter when you're doing transformations. Let's go ahead and take a look at the quick notes. The quick notes basically just says a composition of transformations is 2 or more transformations back to back. The order that you do the transformations can change the final location and often does. Keep track of things by putting a non-prime, then a double prime, a triple prime, and so on, so that you can follow along. What we are going to do now is it says complete the following composition of transformations to transform triangle ABC in the desired order. So the first one is translation of negative 9, 2. So we go left 9, up 2, and we draw our triangle so we can see where it's at, and we call it A prime, B prime, C prime. Then we're going to flip over the x-axis. You know how to do that. It was originally 4 above, so now it goes 4 below, and you do the double primes. And now that you're at the double primes, you are going to rotate 90 degrees around 0, 0. So you can go over and take your points, and you know the rules from our previous lesson about how to make a point rotate by 90 degrees. Remember that it is going to be flip it, and it's going to be negate the one that comes first. So that's what we did, and you could see the new location. So that was after the composition of transformations. On the next one, you're supposed to describe what is happening here. So it appears going from the non-primes to the primes, it was rotated by 90 degrees around 0, 0, ended up at the A prime, B prime, C prime location. After that, it is reflected, and it's reflected over a horizontal line, which is y equals, and it's at 1, so y equals 1. And then the third thing seems to be you are moving right by 8 and down by 3. So that is going to be the composition in that order that would bring the non-primes to the triple primes. And the next one says, while the order sometimes matters, give an example of a set of any two transformations where it does not matter. There's a diagram if you want to try things out. One of the things would be if you reflect over the y-axis, then the x-axis, or if you reflect over the x-axis, then the y-axis, they end up in the same exact location. So that would be an example where the order did not matter. Now let's move on to the homework. Complete the following two transformations. So the first one is you got to flip over the line at of x equals 3, so that's a vertical line at 3. You can see all the points on the right need to go to the left, and then you flip over another line, which is x equals negative 2. Now, the fill in the blank part says, looking at this, what can you say? Two reflections over parallel lines seems to be the same thing as a what? And it seems like it just shifted. So that's the same thing as a translation. Okay, and we could even write down the translation that it is. This is when you're reflecting over parallel lines, not intersecting lines. Now on this next one, they asked you to reflect over y equals x. That's that diagonal line where you count the number of diagonals to get to the line and go the same number on the other side. So we have our new location, and then I'm going to reflect over the y-axis. These are intersecting lines that it's reflecting over, and the question then becomes, two reflections over intersecting lines is the same thing as a single what? And it appears to be a rotation. So that is correct. Two reflections over intersecting lines is the same as a rotation. The next one says, what is a single translation that would be the same as two translations together? So when you're looking at these, it says go left by 3 and then go right by 5. Instead of going left by 3 and right by 5, if all you care about is where you end, what is the same thing that would do that, but just doing it in one step? That would be going right by 2. Then it says go up by 1 and down by 2. What's the same thing that would be the same end location if you went up by 1 and down by 2? It's going down by 1. And let's go ahead and move on to number 4. Number 4 says list the transformations used in the following diagram. What is the composition of transformations? Be sure to use correct notation to give the specifics. So the first thing is it appears going from the non-primes to the primes. It has rotated by 270 degrees around 0, 0, and it ended up in that location that it's in now. Then it appears that it has flipped, it is reflected, so it's going to reflect over a horizontal line that's y equals -2. And then once you have that, it looks like it has gone over by 5, 1, 2, 3, 4, and 5, and up by 3 to be in its final location with the triple primes. Hopefully that made sense. And this last one right here, you're supposed to actually do the composition of transformations. So the first thing we're doing is reflecting over a vertical line at 5. Any points, since all of them are on the right of the line, they're going to all go to the left of the line, the same distance. Now that you have that, you are going to rotate all the way around 0, 0 by 90 degrees. You can use your rules that you have down that talk about rotating 90 degrees. I keep doing 90 degrees. I don't know why. The rule is AB becomes negative BA. So if you take all your points and then you rotate it by using that rule, you could see where it ends up at B double prime, C double prime, A double prime. And then from there, we are going to go left by 2 and up by 4, and you get to your final location. And hopefully that made sense. All right, so once again, the summary here is that we are talking about a composition of transformations, which are two or more transformations back to back. Order often does matter, so just go by the correct order, and then keep track of everything using prime, single prime, double prime, triple prime, and so on. Thanks for watching.